Hey guys, Kyle here. Today's notes video will review graphing a line given its slope-intercept form, often written as y equals mx plus b. If you remember, the constant b represents the y-intercept of the equation, where the line will intersect the y-axis and when x equals 0. On the other hand, the coefficient of the x variable, represented by the letter m, is the slope, or the steepness of the line. M as a fraction represents the rise over run of the line, or to put it another way, the change in y per change in x. If m happens to be a whole number, for example 3, then the slope can be written as 3 over 1, meaning that the y-coordinate increases by 3 every time the x-coordinate increases by 1. If you didn't remember what b and m were, make sure to write them down and remember them in the future. To start graphing the line, you'll first plot your y-intercept, the point 0, b. Let's use y equals 1/2 x plus 1 as an example. Here our b value, the constant, is 1. Therefore, the y-intercept is 0, 1. Then you can draw a slope triangle from the y-intercept using the slope m. Find the numerator of m and draw a line vertically that many units, so in this case 1 unit up. And then find the denominator of m and draw a line horizontally that number of units, so in this case 2 units to the right. Where that line ends is another point on the line of the equation. Just make sure that this point is on the lattice lines of the graph. Draw the line through those 2 points and you formed your slope triangle. While you'll learn in geometry that through any 2 points exists exactly one line, for now you should make multiple slope triangles and find multiple points on the line before using a straight edge to draw the line through those points. This will yield a greater accuracy and help to ensure that you don't make any mistakes. Now here's the part I know you're all excited for, the practice problems. I encourage you to pause and try these problems for yourself, or at least to try to imagine what these graphs will look like, where the y-intercept is, and how steep the line is. Okay, and now that you've tried these problems for yourself, I'll go over them with you. For problem number 1, we're given y equals 7 over 2x. We can easily tell that m, or the slope, is 7 over 2, but what's the b value? Well, it's 0. If there's no constant being added to the equation, b, or the y-intercept, is going to be 0. Now that we know that, we can start graphing. We'll start with our y-intercept, which is again the point 0, 0, and then we'll draw our slope triangles. Our rise, or change in y, is 7, so we'll draw a line up 7 units. And our change in x is 2, so we'll draw a line right 2 units, and ta-da, there's our second point, 2, 7. Keep in mind that 7 over 2 is equivalent to negative 7 over negative 2, so we can draw our slope triangle in the negative or opposite direction. Our change in y from 0, 0 will be negative 7, and our change in x will be negative 2, giving us the point negative 2, negative 7. Small side note, you can manipulate slopes like this by multiplying by any big one. In this case, we just multiplied by negative 1 over negative 1. You can draw as many slope triangles as you'd like, but I'll only be doing 2. Connect the dots, and you've got the line representing the equation y equals 7 over 2x. Problem number 2 gives us an m value of negative 3 and a b value of 3. So let's start graphing. As always, we'll start by plotting our y-intercept, 0, 3 in this case, and then we'll do our slope triangles. Remember to start from the y-intercept, not always 0, 0. Our slope, negative 3, if you remember, can be rewritten as negative 3 over 1. So our rise, or change in y, is going to be negative 3, and our run, or change in x, will be 1. Doing this twice, we'll get the points 1, 0, and 2, negative 3. Draw our line through these 3 points, and we've successfully graphed the equation. Notice how lines with a positive slope, like in problem number 1, will trend upwards, while lines with negative slopes, like in problem number 2, will trend downwards. Problem 3 is a bit trickier. We can do that b is equal to negative 5, but what is m? Well, just like when the b value was missing from the equation, this time m is equal to 0. Well, what does this mean? It means that for every time that the x-coordinate increases by 1, the y-coordinate is going to, well, not increase. It's essentially equal to 0 over 1. And this will give you essentially a horizontal line through y equals negative 5. The line of this equation can also be defined as the set of points which satisfy or make true a given equation. So this can be thought of as all of the points where y equals negative 5. And then lastly, for problem number 4, we can clearly make out the slope and y-intercept given as our m and b values again. Our y-intercept is going to be 0, 1, and our slope will be 6 over 5. Drawing out a slope triangle in the positive direction with a height of 6 and a length of 5, we can get the point 5, 7. The slope triangle in the opposite direction will have a height of -6 and a length of -5, and it'll give us the point -5, -5. One last time, we'll draw a line through all of those points, and there we go. It's the graph for y equals 6 over 5x plus 1. I hope this review has been helpful to you in graphing lines given their slope-intercept forms. Good luck and have as much fun as it's possible to have in a high school math class. And always ask questions if you need help.